Hello, ROS developers around the world, and welcome to a new open class. Welcome, everybody. So today we are going to be talking a little bit about how to use AI, more specifically ChatGPT, in order to help us program robots faster. Yeah. So it's going to be a very interesting class. I hope that you stay here with me and that you can get some important insights from this class. As always, we are going to be doing a lot of practice. So yeah, well, hello everybody. Let me know, please, before anything, if sound is fine, video is fine. I think so from what I can see here, but I would really appreciate if you can give me some feedback. I can see there Hector says it's fine, sound and video is fine, also Alan, also Gilbert, hello there Gilbert. Okay, so everything seems to be fine, which means that we are ready to get started. All right, then yeah, let's jump straight into the class. So let me start right now by sharing my screen. There we go. All right. So yeah. Okay. Let me go to the open class page, which should pop up somewhere around here. I'm not seeing the link, so let me just go like this. Okay. Okay. There we go. So here I have all your comments. All right, then some of the names that I am seeing here, also Pira. Hello, Pira, there. So some of the names that I can see here, it's not your first time. You're already veterans, right? You're already open class veterans, so you already know how this works. But in case that we have any newcomers, so yeah, these classes are very practical, so we put a lot of focus on doing practice, right? And making them interactive, okay? So everything that I'm going to be doing, that I'm going to be showing, you are going to be able to replicate exactly the same from your home, okay? And in fact, I encourage you to do that, right? I prefer that you are trying all the stuff by yourselves rather than just sitting there and listening and watching to what I am doing, what I am explaining, etc. Right? Then, because of this, we always create a ROSJECT, which is basically a shareable ROS project based on the cloud that you can access basically just from a web browser. You don't need any setup, any kind of installation, just a web browser, and you can directly access the ROS project, right? Then, in order to get this project, all you have to do is to click in the button that appears here right above the chat, which says fork and open the class ROSJECT, okay? Then let me click here myself. So please, everyone, go ahead and click on this button, and this is going to basically redirect you, as you can see here, to the main ROSJECT page, okay? This is going to take a few seconds to fully load. Also, here in the right side, you have the streaming panel with the video feed, the chat, in case that you want to share any comments, right? So yeah, in my case, I'm going to actually move this to another screen just to gain some extra space here, right? And then let me go back to the class here so that I can have still the chat and see all your comments. There we go. So let me put the chat right here. And yeah, so after a few seconds, right, your ROSJECT environment is going to load, and you are going to see something like this, okay? So first of all, here you have a terminal, right? This is a regular Linux terminal. You can open as many as you want. This one probably for you is going to be opened automatically, okay? Why? Well, because there are some installations being made automatically, right? For some dependencies, you don't need to worry about that. Yeah, but basically this is a regular Linux terminal where you can type commands, etc. All right? Also, you have here the simulation window, which should have also automatically pop up, okay? We are going to interact with this simulation in a moment. And also, you will have here the notebook, which is what we are going to be following for today's class. Okay, here is where you are going to find everything that I'm going to be doing, all the commands, everything is going to be explained here in the notebook, right? Okay, then yes, is everyone set up? Have you all been able to get a copy of your ROSJECT? Any problems so far? In the meantime, let me also tell you that besides redirecting you here to the main ROSJECT page, also, by clicking on this button, you have created a permanent copy in your account of this project. What does this mean? This means that if you come whenever you want, tomorrow, next week, next month, if you log into the construct and go to the My ROSJECTs area here in the left menu, if you go to My ROSJECTs area, you are going to find this ROSJECT there. Okay, so you have it there for whenever you want to open it. It's yours, this copy, the copy of this ROSJECT. So are we good? Ajay says that he's new here, no problems. So Ajay, have you been able to get a copy of the ROSJECT and open it? Yes, does everybody have something like this with the notebook, the simulation here opened? Yes. Okay, then I would say that we are good to start. So let me drink a bit of water because it's very hot here in Barcelona these days. All right. Okay, then yeah, so basically today we are going to do a bit of introduction of how to use ChatGPT to program robots faster, okay? I'm going to give some hints about how to write proper prompts for ChatGPT, and also we are going to do a practical example, right, based on this guy, okay? We are going to create a ROS2 program with the help of ChatGPT for this guy here, the FastBot robot, all right? Okay, then very quickly, before getting started, let me introduce you to the simulation, okay? So you have two ways of interacting with the simulation. First of all, the simulation should start automatically, okay? In case that it doesn't start automatically, or in case that you want to restart it for whatever reason, no problem. All you have to do is close here, right? And then you can click on the simulation icon, which is this cube icon that you have here in the bottom bar, right? If you click here, this is going to open the simulation again, okay? So no problem at all. Okay, then you have two main ways of interacting with the simulation. First one is directly through the simulation window, okay? So for this, what you have to do is to click on inside the simulation window to get the focus of the simulation, okay? Now, once you have the focus, you can move the robot using the arrows from your keyboard, okay? The up, down, left, and right arrows. I'm going to start pressing them right now, and as you can see, you can very easily control the simulation and start moving the robot using the keyboard arrows, okay? Also, you have some additional buttons, like for example, you can press capital R to activate the laser visualization, see? So now I have the laser rays activated, and same for deactivating them. And also, you can interact with the gripper. So you cannot see it here, but let me rotate a little bit the view. Yeah, so the robot has a gripper also in the front, as you can see here, right? It has this gripper, and you can also interact with the gripper by using the capital G and F, right? So for example, let me press here. I think it's G to close and F to open. So I think this is wrong here in the simulation. So if you press G, you are going to close the gripper, and if you press F, as you can see, you are going to open the gripper, okay? So you can move the robot forward, around, rotate, open the gripper, close it, etc. Yeah? And meanwhile, also, you can see here, right above the robot, you have what the camera of the robot is visualizing, okay? So this is just in case that you want to play a little bit with the robot, yeah? So you can just move around like this and play a little bit, okay? All right, then let me go back. And also, of course, right, because this class is about robotics, and specifically, we are going to be using ROS2. So, of course, you can also interact with the simulation using ROS2. Yeah. So, for example, very quickly, we can visualize some data from the robot using RVs with the following command. Okay. So you can, for example, copy this command here directly from the notebook and paste it into a terminal, right? Paste. And this is going to open RVs with an already pre-configured file. Yeah, so this is going to automatically open another window where you are going to be able to see the RVs2 application. And in this case here, I think that in the file, I have added the camera display. Oh, let me reconnect. There we go. Yeah, so here we have RVs, and we can see the model of our robot, and also down here, the camera visualization, okay? And then also, of course, you can discard. Let me just close RVs. So, of course, also you can run a ROS2 topic list, right, in order to have a quick look at all the topics that are available here for the robot. Yeah, so we can see here some camera-related topics, command bell, also odometry, scan for the laser, etc. Okay? Yeah. Now, for example, also for controlling the robot, for sending velocities to the robot through ROS, we can use the teleop2is keyboard program very easily. Yes? You have the command here. So again, you can just directly copy it from the notebook and paste it here into the terminal. Yeah? So here, basically, we are running the teleop2is keyboard command, very well-known ROS program that allows you to basically teleoperate a robot through the keyboard, yeah, by sending velocities to the motors. And in this case here, we have these extra fields because we are remapping the command bell topic to FastBot1 command bell. Yeah, because actually our robot, as we can see from the ROS2 topic list, uses the FastBot1 command bell. So with this robot, with this command, sorry, let me execute it, and then let me put the robot here. So again, having the focus now in the terminal, not in the simulation, we can also control the robot, move forward, rotate, etc. Yeah, now we are using ROS commands. Okay? And to stop the robot is just the key. The key key. Okay, this one, key. This is to stop the robot. Okay? Yeah, so this is from ROS. And then one more thing, let me rotate a little bit the robot. Also, you can also command the gripper to open or close using ROS. Yeah? In this case, we need to publish a message into the FastBot_1 robot action topic. Yeah? This topic uses string messages, and we can send the string open_gripper or close_gripper in order to control it, right? So for example, let me try first in this case the close gripper command. So let me put again here the terminal, paste the command, and this is going to close the gripper, as you can see with the robot, yeah? And I can open it again just by changing the string to open gripper instead of close gripper. There we go. Okay? So quick introduction to the simulation, how you can interact with the simulation. You can do it directly here from the simulation screen, but also, of course, using the typical ROS messages through topics, etc. Okay? Yeah? So far, so good? Has everybody been able to play a little bit with the robot? ROSJECT open, says Alan. Good, okay. Excellent. Excellent. Okay, then let's keep going. So let's keep going. All right. So yeah, then this robot that we have here is the FastBot robot, right? That we have created. It's a very cool robot which allows you to put into practice many different ROS concepts, right? From navigation to perception to manipulation to AI, etc. So here you have a link to the robot in case that you want to have a look and purchase one of your own. Yeah, here you have the link to check the BotBox warehouse lab, where you are going to get 3 of these robots, right? With also environment to put them in order to practice many different concepts with already predefined ROSJECTs and many different teaching scenarios, okay? So very cool kit for practicing, but also for teaching or even learning yourself about robotics, okay? And then also, let me add something. If you would like to have the chance to win one of these robots, right? Actually, like this one that I have here, let me show you here real quick. Here I have one of these ones. If you would like to win for free one of these robots with LiDAR, camera, and all the sensors, completely for free while learning ROS and while having a lot of fun, you should stay until the end of the class, because I'm going to show to all of you something very interesting that is going to also provide you the chance of winning one of these robots completely for free. Okay, so stay tuned. All right, so let me go back to the ROSJECT. And now, yes, I think we are ready to get started, right? So with all the proper introductions being made, LiDAR is on top of robot, not detecting the objects. Yes. Yeah, no worries. So we are not going to be using the LiDAR for today's class, Alan. So don't worry about that. Okay, so I'm pretty sure that everybody knows already what is ChatGPT at this point, right? So I'm not going to spend much time introducing you all to ChatGPT, but I want to put more focus in how can ChatGPT help you program robots faster, or why use ChatGPT for robotics, right? So ChatGPT has many implementations and can help you in many different aspects in robotics. For example, here, there are some of them, right? Like, for example, write ROS nodes in Python or C++, fix bugs by explaining error messages and suggesting solutions, right? Another very important thing with which ChatGPT can help us. Design algorithms like PID controllers or finite state machines. Learn faster by simplifying ROS concepts or Linux tools, or even explaining robotics concepts, theoretical robotics concepts. And finally, also, by prototyping ideas before implementing them in full, yeah? So ChatGPT can help us in many different fields, right? From directly writing code, on helping us in creating code, ROS2 nodes, etc., to finding bugs, to better understanding APIs or robotics concepts in many different fields, okay? Now, here I want to focus a bit more in ChatGPT for robotics, right? So all of you are probably into robotics, right? So you know that robotics is a very complex topic, right? And more specifically, robotics programming includes many layers of complexity, right? From having to know the middleware to use, in this case ROS or ROS2, right? To having to deal with simulation tools like Gazebo, etc., right? We need to also know about hardware, we need to know about math concepts, robotics theoretical concepts. So robotics is a very complex topic, right? And it requires to have knowledge in many fields, right? Then here I want to use ChatGPT, right, for allowing me to stay on a higher level of a problem, right? So here you can see that I have highlighted this sentence here, yeah? ChatGPT helps you move from idea to implementation faster, okay? So personally, this is a personal opinion, but for me as a robotics engineer, I have been working with robots for many, many years. There is some point where it's impossible to memorize certain kind of things, right? Like, for example, certain ROS-specific syntax, right? And actually, it's not so important, right? So it's not that important for you as a robotics engineer that you know exactly how to write a specific line of code of ROS, right? That's not really that important. What is important is that you are able to understand problems, right, on a higher level, right? Then ChatGPT can help us very well in filling in the gaps at a lower level, okay? Does this make sense? Let me go back here to the chat. Will we have access to this recording? Yes, Ingmar. So we will publish in this class in our YouTube channel. Okay, so yes. Did you pick, Vangelis is asking, did you pick ChatGPT for a specific reason? I guess the presented principles can be applied to other LLMs too. Yeah, yes, you are right, Vangelis. So I just picked ChatGPT because probably it's the most known all around the world. Yeah, but yeah, basically this can be applied to other LLMs, yeah. It makes sense, says Alan. Also the other Alan, we have two Alans today. Yes, understand, okay. So, my recommendation, okay, now to try to summarize all this, would be that you use ChatGPT to help you in the lower level tasks, right? Like, for example, writing code or finding things that are not really so important, but you need them, right? Like, for example, this, yeah? Writing a specific Python code, remembering how it is the structure of a specific ROS command, right? Helping you debug a specific error message, this kind of stuff. Okay, so that you can stay on a higher level of abstraction, right? Then this is how we are going to do our example, okay? But before that, also I would like to quickly go over some hints when writing good prompts for ChatGPT, okay? So this is something that oftentimes it's not taking too seriously, right? But it's very important and it really makes a difference, yes? So the quality of your prompt is going to affect massively the results, the response you get from ChatGPT, okay? So here are some quick tips for when writing prompts for ChatGPT, okay? So for example, be clear about your goal, okay? So here you have a very bad example, which is help me with ROS, okay? Obviously, this is very obvious. It basically says nothing, yeah? You have to be clear and specific about your goal. For example, a good prompt would be this one. I want to write a ROS2 node in Python that subscribes to a common bell topic and prints the linear velocity. Straight to the point, very specific, and providing the necessary information, right? Okay? Second hint is to provide context when possible, okay? For example, this is very important for trying to debug error messages, yeah, right? If you are getting a problem when executing your code, yeah, so provide exactly the error message, okay? You can copy exactly the error message you are getting from the terminal and share that with ChatGPT. That is context, and that is very important also. The code snippet, for example, yeah, share also with ChatGPT the code that is giving you problems, yeah, so that it can have as much information, as much context as possible, yeah, and even some more higher level context, like for example, a short note about what you are trying to do, yeah. So for example, here's an example. Here's my Python ROS2 node, yeah, and you would provide to ChatGPT your Python ROS2 node, your code, okay? I'm trying to publish odometry, but I'm getting a type error, yeah, and you should also share with ChatGPT exactly the type error that you are getting. Can you help me fix it? For example, this is a good prompt where you are providing context and all the information that ChatGPT needs in order to properly process your request and provide a helpful answer, okay? Another hint, the third one in this case, would be to be iterative, okay? What does this mean? This means basically to treat ChatGPT like a conversation, okay? You don't need to create every time a new prompt, okay? In fact, it's much better to establish a conversation with ChatGPT, okay? So you can start with high-level requests and then start doing more concrete, more specific questions, yeah? So ChatGPT is going to remember your previous prompts, your previous questions, yeah? So talking with ChatGPT as a conversation is going to also be very helpful and save you a lot of time, yeah? And finally, ask for explanations or use code. So you can tell ChatGPT what you prefer. Can you just give me the code with an explanation? So you can ask ChatGPT for something and excluding the explanation, okay? I will show an example of this right now. It's very simple. Or please explain what each part of the code is doing, yeah? Usually, if you don't specify anything, ChatGPT is going to give a lot of information, which oftentimes, especially if you are not a beginner, right? It's unnecessary, yeah? So many times you can just explicitly tell ChatGPT to avoid extra explanations, right? But other times it's going to be very good also to get more in-depth explanation about specific codes, okay, that you need to understand, APIs, for example, that you are not familiar with, etc. Okay? Yeah? So basically, prompts are very important, yeah? Writing good prompts is going to drastically increase your results, and it's going to make you get results much faster. Okay? Yeah? Does it make sense? Any questions so far? Any comments? Is it clear? All clear? Makes sense? Okay, excellent. All right, then let's get started. Let's go with the practice. Let's create some code ourselves, okay? Then how we are going to attack the problem? Okay, step one is going to be the idea, yeah? So we have to, basically in this step one, what I want to do is to get a high-level idea of what you want to achieve with the robot, yeah? Let's start with a high level, and then step by step we can get more specific and go into lower levels, right? But first of all, a general idea. What do I want to do? Okay, so for this case, what do we have? We have our robot, and we have some random cubes here with some ArUco markers, right? So what can we do? Okay, well, something we can do is to try to first detect these cubes, right? And then go towards this cube, one of these cubes, for example, in order to pick it, yes? So I want my robot to detect one of these cubes using the markers, go towards it, and then pick it up. Okay, this is a high-level idea of what I want to do with my robot, right? Okay, so I have my idea, I have my objective, right? Then what am I going to need to achieve this? Well, first of all, a ROS2 node, okay? I want to do this using ROS2, so I'm going to need a ROS2 node. In this case, I'm going to do it using Python, but it could be done also with C++. Yeah? I'm going to need to be able to move the robot somehow, yeah? So my ROS2 node has to be able to move the robot. My robot also has to be able to somehow detect the cubes, right? It has to be able to detect these cubes, where they are, and finally it has to be able to pick the cubes, right? So I have my high-level idea of what I want to achieve, what I want my robot to do, and I have also some lower-level information, okay? So my step 2 is going to be to create a boilerplate. What does this mean? This means that I'm going to use ChatGPT to create the bare bones of my program, of my ROS2 node, okay? And for this step, remember to be clear about the goal, okay? So this is the example. This is an example ChatGPT prompt, and this is the one that I'm going to use, okay, for the example. So create a ROS2 node in Python that does the following. Defines a publisher to send twist messages to a topic named FastBot1 command bell. Defines a subscriber to a topic named FastBot1 camera image raw that uses image messages, okay? And how I know this information? Because I have done a ROS2 topic list previously, okay? So I know all this information, yes? I know that the robot has a topic where it publishes the camera data. I know that the robot has a command bell topic also to send velocities to it, right? And then I also know that the robot has another topic named robot action that I can use to open and close the gripper, right? So I am providing all this information to ChatGPT, yes? Define the subscriber. Okay, now also I say, in the camera callback, display the images using OpenCV, okay? So all the cameras that are being captured by, all the images that are being captured by the robot's camera, I want to display them using OpenCV, okay? This is the typical approach if you work with perception, okay? Yeah, so this is an example of higher level knowledge versus lower level knowledge, right? So I know, because I'm a robotics engineer and I have experience working with robots, working with cameras, etc., that if I want to process camera data, right, I'm going to need to use OpenCV, okay? But I don't remember exactly the functions, the lines of code that I need to use from OpenCV in order to display, for example, the images, in order to convert the image from ROS format to OpenCV format. All those code, I don't remember how it is, but I know a higher level, yeah? Then I am providing this request to ChatGPT from a higher level so that ChatGPT can deal with the lower level. Like, for example, what are exactly the lines of code that I need to use to do this, right? Another option could be that I go here and I say, for example, to Google, how to display an image using OpenCV. Yes, I can do this and then go to the documentation, have a look at the documentation, look for the lines of code, yes? But this is going to take me much more time, yeah? I prefer to provide this information to ChatGPT so that it gives me everything with a single prompt, right? So in the camera callback, I want to display the images using OpenCV. You are going to deal with how the code is and all that stuff, okay? Yeah? And then finally, also add a publisher to send string messages to a topic named FastBot1 robot action. Okay? So this is the full prompt that I'm going to write to ChatGPT. Okay? And this is the provided code in the answer. Okay? I have been doing some tests before this class, and this is, for example, what ChatGPT gave me. Okay? But I want to do it live also now. So actually, let me open ChatGPT. Okay, I think I'm going to need to. Can I continue with Google? Maybe. Don't I have any session already started? It doesn't look like. Okay, there we are. Here I am in my account. Okay, then I'm going to start a brand new chat here, okay? And I'm going to use exactly this prompt here, yeah? So let me get the prompt and paste it to ChatGPT. Create a ROS to know, okay, send. And here you have the response from ChatGPT, right? I don't know if it's going to be exactly the same as the one I have here. Yeah, because there can be differences between iterations, between responses from ChatGPT, okay? But it looks pretty similar, okay? So for this class, I'm going to use the one that I am getting right now live, okay? Yeah, so yeah, you can see here, right? So it has created the node within a Python class. I can see here a publisher for the FastBot1 command bell. I can see another publisher here which uses a string for FastBot robot action. I can see a subscriber for FastBot1 camera image raw. So everything looks kind of correct, right? Okay, then let's test it, right? So next step would be to test this code. Okay, very well. ChatGPT has provided me the code, but I should better test it now, right? Then for this, well, I need a package, okay? So let me create the package. If you don't remember how to create a package, by the way, you can also add ChatGPT. For example, let me do that here. Give me the command to create a ROS to Python package. No extra explanation. Just give me just the command. Give me just the command. Okay, I don't want him to start explaining me what is a package. Just give me the command. ROS to Python package. Okay. There we go. Here I have the package. The command exactly to create the package, right? So, yes, let me copy it and paste it. It has many dependencies here, however. Okay. Paste. I am in the proper place. ROS to package, FastBot controller. Okay, there we go. Clear this. Okay. I require the package name. Oh, okay, so it has an error, okay? So, yes, by the way, ChatGPT sometimes can fail, okay? But yeah, this is why always there's going to be a robotic developer which is supervising all the steps and has a higher level knowledge, okay? In this case, the error is super stupid. It's basically that it has put the package name here and it should be earlier, right? So let me just fix this real quickly. So build type, ROS to package create. Okay, so let's put the name here. It was FastBot controller, for example. FastBot controller. There we go, okay? So now we can open the code editor. Let's open our code editor here from the ROSJECT so that we have a graphical access to all our files, etc. Then here inside our ROS2 workspace, we are going to have our newly created ROS2 package, FastBot controller. Okay? Yeah, you can name the package however you want. All right? Yeah? And then what I should do here is to just create my program, right? So I don't know, let me call my program as detect cubes.py, right? And then I'm going to copy paste directly the code that ChatGPT has provided to me. Copy and paste. There we go, copy and paste. Okay, and now I need to compile it, okay? So let me add here. Also, if you don't remember how to do this, for example, this is something that you can very easily forget, right? So for example, how do I generate an executable from a Python script? I remember that I have to put something here inside console scripts, but I don't remember exactly. So again, we can use ChatGPT for solving this kind of stuff also. Yeah. So what do I need to add to entry points to generate an executable from the Python script? What do I need to add to entry points to generate an executable from the Python script? Okay. At the following, there we go. And here I have exactly the line that I need to add. Okay? So that I don't have to remember these lower level details, right? Okay. Then, yeah, so let me put this here. And then here we have, for example, you can change this however you want. This is the name of the package, FastBot controller. In my case, I have named my Python script differently, so I need to change this, right? This is going to be detect cubes, and for the node, I'm also going to call it detect cubes node, for example, okay? And there we go. All right, so we are ready to compile, call build. Source, and then run my program. ROS to run, FastBot controller, and the node is detect cubes node. Okay, so let's see what do we get. FastBot controller node has started, and my graphical tools open, and I am already seeing here the output from the camera, right? Let me try to move a little bit the robot, so that to see if we can detect the cubes. Now here we should see them, and there we are. Okay? Yes? So basically, this is the prompt we have used, and this is exactly what I have gotten, right? A Python, a ROS2-based Python node with a publisher for velocities, a publisher for the robot action, a subscriber for the camera, and inside the camera callback, I am basically printing the images using OpenCV. I am printing the images that the robot is capturing, yes? And all this lower level stuff is handled by ChatGPT. I don't need to remember exactly all these lines of code, right? Yeah? Are we following? Are you following, guys? Let me have a look at the chat. How accurate ChatGPT code is it's pretty accurate. As you can see, of the code that it has provided, it works perfectly, okay? It's not going to be always like this. Also, it depends on the level of complexity. It depends on many factors, okay? But yeah. Okay, what if we have only the idea, we don't know what we need to do? This might be much trickier. I mean, what you need is a high-level idea of what you want to do, Vangelis, okay? For example, my first idea is high level, it's very high level, yes? I want my robot to be able to detect the cubes and pick them up using ROS2. This is the high level idea, yes? Then from there, you go down. You start going down into lower levels of specification, okay? But for the first idea, you have to keep it high level, right? And that I think it's very doable, right? Even if you are not an expert in robotics. So far, so good. How do we create the boilerplate? Well, this is what I have just explained. Chukuma. This is what I have just done. Create the boilerplate using this ChatGPT prompt. Yes? So I have passed this prompt to ChatGPT right here, and then ChatGPT has provided me directly the boilerplate for my program. Yes, which I have executed here, and it seems to be working. Yes? Right? And then, again, for example, this is something that I have not included here in the notebook, but this is a demonstration that you can establish a conversation with ChatGPT, right? So for example, you can see this image. By the way, this image here looks very small, right? And it looks so small because the camera resolution that this simulation uses is small, okay? So that's why this image is very small. But we can establish a conversation now with ChatGPT, for example. I can tell him, the display for the image is very small. Can you make it bigger? For example, yes? So now this is a conversation. I have already asked some things to ChatGPT, so now I'm assuming he has all that knowledge, so I can ask follow-up questions based on the previously asked ones, yeah? So, hey, the display for the image is very small. Can you make it bigger? Okay, and then it is giving me this. Okay, it's explaining me exactly here how to resize, right, the camera, right? So for example, let me try, I can try directly this. I'm going to do that. Try. I need to do something like this, right? Okay, so let me recompile my code. I'm going to stop this. Call con build source install. Okay, there you go. Okay, yeah. So now I have another image which actually can even be resized. Yes? Pretty cool, actually. Okay? Yeah? And this is just doing follow-up questions based on what I have already asked ChatGPT, right? How do create the boilerplate? So far, so good. Yes, but the prompt requires some level of ROS knowledge. In case someone is totally new to the topic, she won't be possibly able to create. Yes, yes. So, Vangelis, obviously, you are always going to need a level, a basic ROS understanding, right? Obviously, you're not going to be able to do any of this. So yes, a minimum ROS understanding is required. Yes, yeah, that is for sure. I mean, not just to be able to write better prompts, but also because you cannot trust 100% everything that ChatGPT is going to give you. Yeah, so you as a developer are going to be there to review, to check that what ChatGPT is doing is correct, right? You cannot rely 100% in ChatGPT to do everything for you. So no, that's not possible, right? So you need to have some basic knowledge of ROS, obviously, in order to be able to interact properly with ChatGPT, right? So remember, this class is not how to use ChatGPT for doing everything for you. No. This is not the topic of the class. Yeah. So this is how to use ChatGPT to program robots faster. Okay. So I already know how to program robots, right? I know. But I'm going to use ChatGPT, I'm going to use AI to help me do it faster. Okay, this is the purpose of this class, yeah? But if you have no idea of how to program robots, obviously, you're not going to be able to do it even if you use ChatGPT, okay? Yeah? So we already know or have a basic understanding of how to program robots, so we are going to use AI to help us be faster in doing so. Okay, this is the goal and the purpose of this class. Okay, yeah. I am working on a code which is running in one machine but replicating same code. Well, I don't know what that is, Anubhav. I don't know what you are doing exactly, so I don't know what is the problem you are having. Sorry. Okay. All right, so we have our boilerplate, right? Then, next step, complete the details, okay? So get a little bit into a lower detail, right? So now we have our bare bones of our ROS2 node created by ChatGPT, but now I want to start doing more in-depth implementations, right? So for example, in this case, we are going to start by the ArUco marker detections, okay? So one thing I want to do is to be able to detect these cubes. How can I detect these cubes? Well, I can use the ArUco markers that are in these cubes in order to make the detection, right? Yeah? So, what am I going to do? Okay, update the camera callback so that it can detect ArUco markers, right? This is another follow-up question. So right now, my camera callback, all that is doing is displaying the images captured by the camera, okay? If you look into the code, you can see that it's doing other things, like it's converting the ROS image to OpenCV format, and then it's displaying the image, okay? But now I want to add a bit more of complexity. So I want my callback to be able to detect ArUco markers, okay? Ideally, I could provide more details, okay? Because this prompt is pretty generic, okay? But in this case, let's assume that we don't have more information, right? So we are going to use this prompt directly, okay? So let me use this prompt directly here. Update the camera callback so that it can detect ArUco markers. That is going to be my prompt. Okay, here it's giving me some context, as you can see. It's going to use libraries from the Open Country Python, okay? So we should have this installed, and then it's giving me directly the code for the updated camera callback, right here. Okay? Yeah? Okay? Then this, we already have it, okay? This is one of the things that we are installing automatically in the ROSJECT. If you have a look here at the course install sh script, you are going to see that we are already installing this, okay? Yeah? So, next thing to do is to try out the code, yes? So first of all, I should be importing this from ArUco, right? So I can try this. Let's add this import, and then let's update our camera callback. Let me see this. Yes, so, okay. And let me fix here the indentation. There we go. Okay, so here we have the updated camera callback directly as provided by ChatGPT. Okay, so let me rebuild my code. Call build source, and then try to run my code and see what happens. Okay, so I am getting an error. Yes, so here there is an error which says failed in camera callback. Module CV2 ArUco has no attribute detector parameters create. Okay? Then, as you can see, ChatGPT code can sometimes fail. Okay? I know what this error is because I've faced it earlier while creating the class. Okay? But we can also ask ChatGPT about this. Okay? And let's see what it says. I am getting this error when running the code. And I provide exactly the error message. Exactly, okay? So as you can see, I am having a kind of conversation with ChatGPT. Yes, constantly. I am making questions about the previous questions, etc., 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 right? Then here it says, that error typically means your OpenCV installation doesn't include full ArUco module from the contrib package. Solution, install this, okay? Now, I don't want to spend a lot of time on this, okay, but this problem basically is because we have to use for this ROSJECT an old version of OpenContrib Python, okay? Yeah, because of the libraries that are installed in this specific ROSJECT, okay, we need to use a NumPy version lower than 2 and this specific OpenCV contrib version, okay? Then because of this, our ArUco modules don't have this specific function, detector markers, detector parameters create, okay? Right? So, what I'm going to do is to provide this extra context to ChatGPT, okay? This I am trying it live, so I don't know if it's going to be able to find out, but let's see. I'm going to provide this information to ChatGPT, so let's see if it is able to figure it out, okay? I'm using older versions of OpenCV contrib Python and NumPy. I can even provide here the ones that I am installing. I'm installing these ones. I'm using these ones. I'm using this one, for example. Yeah, I'm using older versions of OpenCV contrib Python and NumPy. Okay. With this consideration, can I solve the issue using a different function, for example? Let's see what ChatGPT says. Okay, yes, With OpenCV contrib Python and NumPy2, the function ArUco detectors is not available. Instead, you should use the older method of directly instantiating detector parameters via the constructor. So what should I do? Replace this line by this line, okay? So that's exactly what I'm going to do. So let me replace this line, which I have, here it is. Yes, so I'm going to replace this line. Actually, let me just comment it, for example, and write down, I'm going to add the new one, which is this one, okay? Yeah. This is the full updated callback, again, with this change already applied here, okay? Yeah. So, all right, let me recompile my code. And rerun my program. And voila, now it works. Okay? Yeah? So I have used ChatGPT to, first of all, update my node, and second, also to fix issues that I was having, right, while trying to make my code work, okay? Still, this doesn't seem to be working, right? Let me try to get a bit closer to, let me check actually something. Okay, yeah. So let me get closer to, if I can, to one of the markers. No, for example, I'm going to try to get closer to this one, just to get a better view of the marker. Actually, I'm going to move using ROS. It's going to be much more precise here if I use the keyboard teleop program. So let me do that right in a moment. Let me grab the command from here, paste it here, and then I'm going to try to get as close as possible to the marker to have a good view of it. Okay, there I think I have a pretty good view of the marker. So maybe I can even, sorry. Okay, there we go. That should be good enough, okay? But still, my program is not doing any detection, right? So just having a quick look at the program, if there are detections, right, we should be getting some log messages like this one, detected ArUco ID, which we are not getting, right? Okay, so still something is not working properly, okay? So what would be the next step? The next step is going to be step number 4, solve potential issues, okay? So we have already used ChatGPT to create our structure of the code and to start doing more specific implementations, like in this case, doing ArUco detections, right? But it's not working. Yes, and this can happen. This can happen. Robotics are very complex, so this can happen. Now, what can we do now? Okay, so we can ask ChatGPT, right? So we can still use ChatGPT to try to help us debug this program, right? So for example, in this case, what I'm going to ask ChatGPT is the following. Yeah? The program is not detecting the marker. What could be the problem? Yes? Very general question, right? But if we don't have more specific information, let's see what ChatGPT can tell us, and maybe it can orient us towards what could be the problem, yeah? So, if your ArUco marker is not being detected, here are the most common causes and how to fix or debug them step by step. Number 1, wrong dictionary. It says, the ArUco marker must match the dictionary you're using in the code. You are using this one. Yes, this means that your marker must be from the dictionary 4x450 family. If your marker is from another dictionary, like whatever, it won't be detected. For example, confirm the dictionary you used to generate the marker, try printing or changing the dictionary, okay? This is the first option that ChatGPT gives us. It provides other options, okay? But we are going to stay in the first one because it happens that this is actually the problem that we are having, right? The very first option that ChatGPT gives us, this is the problem that we are having, okay? Yeah? Are you guys following? Let me, because a lot of information, so let me do a quick break here to see if everyone is following. Are you following my steps? We are almost done, okay, guys? So we are reaching the end. I think my chat maybe got stuck. Let me refresh this. Yes. Okay. Hey, wait! I have missed many messages. Okay. Okay. I think that now my messages are up to date here, right? So the last message is from Alan that says all is clear, right? Okay. Then. Yeah, I think so. I think so. Here. Okay. Okay. So let's continue. Okay. Then all right. So here you can see the one that I was doing while testing, while also the first option that ChatGPT gave me is dictionary mismatch, okay? Then here is not specifically mentioning nothing like that, at least I cannot see it, but in my previous attempt, ChatGPT told me something like this, see? You can iterate through dictionaries to test which one detects the marker. I can give you a script to help with that if you want, yeah? And then automatically when I saw this, I reply it to ChatGPT. Okay, give me a script to find out the proper dictionary. Okay, so I'm going to use this prompt and let's see if ChatGPT gives me the same. Okay, this is the code that it provided me when I was doing some testing earlier. So I'm going to try the same script. Let me specify here based on an image. Okay, so here is a Python script that will try all standard ArUco dictionaries on a given image and tell you which dictionaries detect one or more markers, the IDs and number of markers detected per dictionary. Okay, and this is the script that it's giving me. Okay, so I'm going to test this script directly. Okay. So let me do that. Okay, so detect ArUco dict.py. Let me just use the same name for the script. So new file, detect ArUco dict.py. There we go. And then copy and paste the program. Okay. Then, as you can see from the beginning of the program, this program needs an image of the marker in order to analyze it. Okay, so this, you can do it very easily, for example, getting it from the simulation or whatever. In this case, I have already included an image of the ArUco marker that I have used earlier for detection, okay? Here is the image that I have taken earlier from the simulation, okay? But this is just a screenshot from the simulation, okay? So no big deal. I can even, I'm going to use this one because I'm now in a different computer and I don't really know how to take a screen capture here. So I'm going to use this one that I already created earlier, okay? So here I have an image of my marker. So I'm going to use this one in the program. So basically just change the image path from marker GPG to ArUco image dot PNG. It's a PNG, so there we go. Okay, then let me try this script. Let me run it directly like this, Python 3, detect ArUco dict.py. Okay, so this one is giving me the detection. It's not showing anything else, okay, right? But it's giving me the detection, see? So, detected one marker with dict 50 ID. Okay, actually here it's detecting, here it's giving me other IDs for some reason. Let me run this again. Okay, that's interesting. But the first detection is this one, 5x550, but there are also others like 5f5, 100, 200, 1000. Okay, anyways, for example, let me try here the code, the version of the code that I got earlier, which is, actually it's pretty similar, okay, but probably there are some small differences. So let me try this one here and run this one so that you can see this. So this one, as you can see, it's even me. It was even showing to me the detection in the image. Yeah, live detection of the marker here in my image, and here it's telling me that this ArUco marker is 5x550. Okay. All right. So with this information, let me stop the program. Let me kill the process, grep Python. Let me kill it like this, 7655. There we go. Okay, so obviously the follow-up question, it's very easy, right? Okay, so, hey, the program has gave me this output, right? So I'm going to write it exactly here. The program to check the dict gave me this. Yeah, this is exactly the output that the program has given to me, right? Where it is here, right? Which is the same that I got from the other program, actually. Okay, exactly the same. Then, okay, so the program gave me this. How should I update my code accordingly? Yes, this is the very obvious follow-up question. And then here, ChatGPT tells me exactly how I should update my code. Yes, which is changing this line, the dict 4x4 by 5x5. Yes, which, let me go back to my code. We have this exactly here. So it would be something as simple as changing this 4x4 by 5x5. There we go. Okay? Yeah? Then let me very quickly rebuild my code. Colcon build source install setup bash and rerun my code. And now I'm having a detection. As you can see, my program is actually detecting one ArUco, which I can also see here being highlighted, right? Okay, so imagine, I don't know about you, right? But for me personally, if I have to figure out what kind of dict it's is this ArUco marker? I mean, I don't know, right? So using ChatGPT with just a very basic prompt, it has provided me a program that automatically analyzes this ArUco marker and gives me the exact dictionary that I need to use to detect it, okay? Without ChatGPT, this would have taken me much more time, right? And this is something that very easily I can get solved with ChatGPT. And this is not something relevant to robotics, right? So I don't care. I don't care what kind of dictionary this ArUco marker is. This is not something important to me. I want to make robots do cool stuff, yeah? I don't care about the dictionaries of ArUco markers. So I don't want to dedicate time to that kind of things and spend a lot of time looking for what is the specific dictionary I need to use. No. I don't want to spend my time on that. I want to spend my time on more important things. So for this kind of stuff, I'm going to use ChatGPT because it's going to help me solve all these kind of problems much faster, yeah? In a moment, with some pretty simple prompts, right? I have a ROS2 node working completely functional, which is detecting ArUco markers in a moment, okay? Without using ChatGPT, would have I been able to do this? Yes. But I can tell you that I would have need to spend much more time, okay? Yeah, because I need to figure out many details which are not really that important. To me, at least as a robotics developer, okay? I don't want to remember exactly what is the function to resize an image using OpenCV, right? Or all these kind of details. I don't want to have to remind about all of that, yeah? So if I can have a tool that is giving me all of this, yes, with just some prompts, that's going to make me develop much faster, and I'm going to be able to put my effort into things that are really important for robotics, relevant for robotics, and that AI is not going to be able to solve, okay? This is something that AI can solve, but there are other robotics problems that AI is not going to be able to solve. So that's where I want to dedicate my time to, right? Not to all these details, okay? Yeah? Does it make sense, guys? Is it clear? Questions? Have you been able to follow up until this point? Absolutely, yes. Okay. Okay, great. Then the class is done, but you are not done yet, okay? So now we have completed the class, we have used ChatGPT, used several different prompts for getting code, for solving errors, and we have now a ROS2 node that is able to detect ArUco markers, okay? Yeah? Now, I have some homework for you, okay? So now that we have this part, you are going to have to complete yourself the missing part, yes? Because now that the FastBot robot is able to properly detect the ArUco markers, you have to update the ROS2 node, this one that we have started creating, yes? You have to update this ROS2 node so that when there is a marker detection, the robot will approach the cube and will pick it up, okay? Of course, I encourage you to use ChatGPT in order to help you achieve this, okay? And in order to pick a cube, all you need to do, it's very simple. All you need to do is to get close enough to the cube and then close the gripper, yes? And then automatically the system is going to handle and is going to properly grasp the cube. You can see an animation here, yes, how the gripper closes and then automatically the cube is attached to the gripper, okay? So we have the first part, we have done the first part, which is the detection. Now using the detection, you have to approach the marker, and then once you are close enough, just activate, close the gripper, in this case, in order to pick up the cube, okay? That part is your homework, and you are going to have to do it on your own, okay? And also, this is what I was saying at the beginning. I was kind of teasing at the beginning of the class, okay? So for the next class, we are going to continue working with ChatGPT and seeing how ChatGPT can help us program robots faster. But specifically for the next class, we are going to be working on the ROS2 online robot racing contest that we have created. I don't know if all of you are aware of this contest that we have created. You have a link here at the bottom of the notebook. okay, you can open it. But for this month of July, what is this? Why is this focused out? Damn, okay. There you go. So for this month of July, we have created this ROS2 robot racing contest, which is based on this Mario Kart simulation, okay? And basically what you have to do is to, using any technique that you want, right? You can use perception, you can use navigation, you can use reinforcement learning, anything, yes? But you have to make the robot complete a full lap to this Mario Kart circuit, okay? And then the person that completes, that is able to make the robot complete the lap in less time, so the one that gets the fastest lap is going to win for free a real robot, okay? So to participate, you have all the details here, okay? But to participate, all you have to do is to basically copy this ROSJECT, and you have everything explained in there, okay? So let me open this ROSJECT myself here. Yes, so here you can copy this ROSJECT just by following this link, and here you have the instructions for the contest, okay? With the simulation and everything included, okay? Then what are we going to do next class? Next class, we are going to use ChatGPT in order to help us find a solution, a possible solution, so that the robot can complete a full lap to this Mario Kart circuit, yes? We are going to use some perception also, in this case, to detect the track and follow the track, okay? Using perception. But that is going to be for the next class. So, so yeah, let me have a last look here at the chat. Very good tools. I can't comment previously. I don't understand your comment, John Alexander. Thank you so much. Can someone have a private discussion with you or your company? Send us a message to our email, Chukuwa. Send us a message to info@theconstruct.ai. Okay, you are going to find our email there, our contact email in our pages. So send us an email there. Yes, it's Umut says perfect idea. Yeah, it's pretty cool, right? So yeah, I really encourage you, all of you, to follow this link. It's here at the end of the notebook, right? And you are going to, in case that you didn't know about it, you are going to be able to get the ROSJECT and see all the details about this contest. And who knows? Maybe you can win this robot for free if you manage to create a program that makes the robot do the fastest lap. Okay. And in the next class, we are going to again use ChatGPT to help us find a solution for this robot racing contest. All together, yes. So yeah, that's all for this class. I'm going to leave it here. Almost 30 minutes past the expected time. I was expecting to finish at 7 p.m. o'clock, and it's so yeah, it got a bit longer at the end. But I think it's been very interesting. I think we have been able to see some very cool things. So I hope that you have enjoyed the class, that you have learned some things, and that you are going to be able to, from now on, start using ChatGPT more efficiently, right? To help you program your robots faster. So yeah, thanks everybody for sharing this class with me. I hope you enjoyed it. I will see you in the next one. I hope to see all of you there in the chat for the next class. And as always, until then, keep pushing your robotics learning. Bye-bye.